Hi everyone, welcome to YourPedia. This is Chandrasekhar, Faculty of Electrical and Electronics Engineering at YourPedia. You all know that ISRO announced its notification for CBT, computer-based test, right, for the recruitment of scientists or engineers, right. It is one of the very good chance for the candidates who are aspiring to join as a scientist in ISRO, right. So ISRO is taking through GATE, that is a different thing, and taking through written exam also, right. For ECE, network analysis is one of the very important subject. Today in this video I am going to discuss some 20 very good ISRO level questions, and in this 20 some 5 to 7 or 8 previous ISRO questions are also there, right, on the basics of networks. Like what do you mean by basics of networks? Are KVL, KCL, Ohm's law, series parallel combination of resistances, these things, power calculation, voltage calculation, current calculation, these things comes under the basics of networks. 20 very good questions of ISRO level I am going to discuss. In these 20, some questions are previously asked ISRO questions at different years, right. So let's enter into the topic. Before you enter into the topic, YourPedia started a dedicated module for ISRO preparation, right. You can join YourPedia module to accelerate your preparation towards your ISRO preparation, right. Enter. What is the equivalent resistance RAB in the given circuit? Whenever the question is asked about equivalent resistance, the first thing is you need to assume yourself you are standing at the terminals A and B. So he is asking RAB means you need to assume yourself you are standing at the terminals RAB. Go there and stand. Now from here you see these two resistances are in series. 5 plus 1 is 6. That 6 is in parallel with 4, right. Now I am doing here, observe here, solution, yes, solution, very simple way. This is means step by step I'll simplify, right. Now if you see this is looking like a zigzag connection, but this B and B both terminals are same, therefore this 12 is in parallel with 4, this 6 is in parallel with the 3. Now let me redraw the circuit first of all. Instead of words I'll redraw the circuit. This is 10, this is 1, this is 1, this is 5, or why 1 and 5? I'll make it as 6. This is 1, this is 10, then 1, then 6 it is, please. After that this is 4, and this D and B, this 12 is in parallel, so I can draw 12 here itself, and I can draw this 6 in parallel with 3. Yes, we have a 3 ohm here. This 6 is in parallel with 3. 6 is in parallel with 3, right. Now this is A, this is B, this is B, right. This is 10 ohm, right. This is 6 in parallel with 3. This is 3 ohm, this is 6 ohm. Just 2 steps are enough to solve, not more than 2 steps. Then how much is this? This is 1 ohm. This is how much it is? 6. This is 4 ohm and 12 ohm. Yes, this is 12 ohm, and this is 4 ohm, and this is 6 ohm, right. Now let me simplify. 3 in parallel with 6, I'll do it in the next page. Yes, I'll do that in the next page, right. Come here all of you. This is A, resistance. 6 in parallel with 3, 1, it will become 1 resistance only, and after that 4 in parallel with 12. After that you have 6, that's all. This is A, this is B, this is 10 ohm. Sorry, here 1 ohm I forgot. Here I forgot about 1 ohm. Let me put 1 ohm here. That 1 ohm we forgot. Yes, there is 1 ohm here, right. This is 6 in parallel with 3. 6 in parallel with 3. This is 12 in parallel with 4. This is 6. Let's calculate 6 in parallel with 3. What is 6 in parallel with 3? 6 into 3 by 6 plus 3. That is 6 into 3 by 9. 3 is 3 2s. So this is simply 2 ohms, right. That is very simple calculation. Parallel connection of resistances formula, that's all. 6 into 3 by 6 plus 3, 9. 3 cities gone, 2 cities. Just for your understanding purpose I did parallel combination. Everyone, even a person who did his 10th class know about parallel combination of resistances. For that a separate explanation is not required. 12 in parallel with 4, 12 into 4 by 12 plus 4, how much it is? 12 into 4 by 12 plus 4 is 16, 4 4 is 4 3 it is. Yes, how much this is? This is 3 ohm and this is 6 ohm and this is 6 ohm, right? This is A, this is B. Now observe from here, again this 6 is in parallel, this 6 is in parallel with 3, that will become 2 ohms. Now RAB will be, this is 10, this is 1, this is 2 ohm, right? This is 10 ohm, this is 2 ohm, this is 1 ohm, this is again 2 ohm, 2 ohm. This is 2 in parallel in series with 1, 3. 3 in parallel with 2 plus 10, 3 in parallel with 2 plus 10, right? 3 in parallel with 2 plus 10 will be the answer, right? 3 in parallel with 2. Yes, let me do it. Let me check the question first of all. Yes, this is 6 and 12 in parallel with 4 will be 3. 3 in parallel with 6 is 3 in parallel with 6 is 2. 2, yes, this is in series 1. To that 1, yes, this 2 is going to be in series 3. Yes, 3. This 6 in parallel with 2 became 2, right? Yes or not? Yes, perfect. Come here. So now it is 10. It is 10, right? Just a minute. Yeah, this is 10. This is 10 ohm. After that, this is 2 ohm. This is 1 ohm and this is A, this is B. This resistance is RAB. This is 3 ohm, right? So RAB is equal to 3 into 2 by 3 plus 2 is 5 plus 10. So RAB is equal to 6 by 5 plus 10. How much it is? 6 divided by 5. 0. How much it is? Yes, 0.12. Yes, 0.12. Yes or not? 1.2, sorry, not 0.12, it is 1.2, please. 1.2 plus 10. Now RAB is 11.2 ohms. Let's see the options. 11.20 ohms, option B for Bombay is perfectly suitable, right? Just for your explanation purpose I taken these many steps, otherwise it is just a simple question, right? Let's go to the next question. Now he is saying find the value of current I2 for the network shown in the given figure. He is asking about I2. He is asking this current. Simple. See, a lot of people will convert voltage source to current source, blah blah blah, many things, but only one step. This is 9 amperes. This 9 amperes is coming, right? Now this is I2. Then what is this current? 9 is coming, I2 is leaving. I will take this one as 9 minus I2. KCL I am writing. 9 is coming, I2 is leaving. Then this current will be, here you apply KCL at this node, 9 coming, I2 leaving. So sum of all the incoming currents must be equal to sum of all the outgoing currents. As 9 minus I2 is entering here, this is plus, this is minus. And as I2 is entering here, this is plus, this is minus. I will write the KVL for this loop. What is that? Minus 36 minus 12 into 9 minus I2 plus 6I2 is equal to 0. Plus 6I2 is equal to 0. That implies, yes, minus 36, yes, minus 108 plus 12I2 plus 6I2 is equal to 0. From this one, 18I2 is equal to 130 plus 14, right? 144. From this one, I2 is equal to 144 divided by 18. 144 divided by 18. Let me calculate this. You can, or normally also you can calculate. Yes, 144 divided by 18. Yes, it is 8 amperes. It is 8 amperes. Normally also you can calculate with 2 stable. You keep on doing it, you get 8 amperes. Answer is option D, 8 amperes. I did with the calculator, but calculator is not allowed. Calculations must be your part. You must be very good at the calculations, right? Next question, please. See, many people will do blah blah blah. Only one equation I wrote. Only one equation. Habituate for this method, right? Next question, please. In the figure shown below, the value of voltage drop across the resistor R1 is asking the voltage drop in the R1. voltage drop in the R1, right? Okay, now observe it carefully. So these were in series, that is in parallel with 40. Now these were in series, 100 plus 300, 400. Now how much is current? That current is 40 divided by 400. Current I call this one as I is equal to 40 divided by 400, that is equal to 0. Simply I can say 40 tens, that is 0.1 amperes. 0.1 amperes. Now voltage drop across R1, voltage drop across R1. So voltage drop across R1 is equal to resistance is 100 into current is 0.1. How much it is? 10 amperes. Sorry, 10 volts. Voltage drop will be in terms of volts. 10 volts it is. Very simple question. Option is B. Just voltage drop is equal to, you may be thinking, sir, these simple questions are asked. As I am telling you, in this 50% of the questions are previously asked ISRO questions, right? Yeah. Next question, find the voltage V1 with respect to the ground in the figure given below. Yes, he is asking about V1, where it is. Yes, he is asking about V1. Yes, V1 is this voltage. This is the voltage V1. Okay, now this current is how much? 5 amperes. 5 into 2, this voltage is going to be 10 volts. We know this voltage. Yes, how much it is? 24 volts. Write the KVL. So this is plus minus V1. Just KVL. Minus V1 plus 10 plus 24 is equal to 0. Therefore, V1 is equal to 34 volts. Nothing doing. Very simple. It is 34 volts. Just a KVL. Just a KVL, right? So I know the voltage drop here. Why? I know the current through this. Why? Because 5 ampere source is there. So he's asking the voltage across that 5 amperes only, that he assumed it as V1. We want to find that V1 only. Then when current is entering 5 amperes, 5 into 2, 10 volts. This is 24. Total is 34 volts. Option is B. Next question, please. In the interconnection of ideal sources shown in the figure, it is known that 60 volt source is absorbing power. So 60 volt source is absorbing power means I1 should be positive. I1 is positive. I1 must be, not is. I1 must be, yes, must be positive. Why this, sir? From passive power sign convention, if a positive current is entering into the positive terminal of a source, I repeat, when positive current is entering into the positive terminal of a source, then it is absorbing. If positive current is leaving from the positive terminal of a source, it is supplying or delivering. If it is for a load, resistance or inductance or capacitance for these elements, if positive current is entering into the positive terminal, it is absorbing. Positive current is leaving from the positive terminal, it is delivering. Right? Now come here. We know that this is 12. Okay, this is 12. 12 amperes. This is also 12 amperes. This is also 12 amperes. Right? Now here for this question, options. See, these are the options given. These are the options given. See, first of all, before we go for options, this is 12. So from in this one, some current is flowing. Positive current only should flow. Positive current only should flow. Therefore, definitely this I should be less than 12. I should be less than 12. Why, sir? If this is incoming is 12, man. If this is 13, then one should come from the 60 volt source, which is not correct when it is absorbing power. Therefore, very simple. 12 amperes is coming. Some I amperes is going. So definitely this I1 should go down. So in 12 something is going, definitely this should be less than 12. So options are this 10 amperes, option B is 14 amperes, option C is 2 amperes. Yes, he's asking about what? He's asking about I1. Yes, yeah, absorbing power. Then I1 is dash. So the question is, then I1 is dash amperes. I1 is dash amperes. Or I can say, instead of I1, let's talk about I is dash amperes. I is dash amperes. I should be less than 12. I should be less than 12. Why? Because in that something must go in the form of I1, right? I should be less than 12. Yes, I1 we can't make a comment, but I should be less than 12, right? 14 amperes. I can say 12 amperes. Option D is 16 amperes. Even it is not equal to 12 also, it should be 10. Why? Suppose if it is 12, if I is 12, entire current is going here, no current is flowing in the 60 volt, If no current is flowing, it is neither absorbing nor supplying. But he is saying that 60 volt source is absorbing power, means some positive current must enter here. In 12, something is going here, then remaining should go here. In 12, something is subtracted, some positive value is subtracted from plus 12, then this I should be less than 12. So based on that, option is A is perfectly suitable, right? Let's go to the next question. In the circuit shown below, the current through the 10 ohm resistance is. He is asking about this 10 ohm resistance. Here very simply, I can say you can apply in many methods we can solve. Take this voltage as V. Now I is equal to V by 10. But we do not have V, sir. We do not have V. Then how to get V? Write the KCL here. Write the KCL here. Yeah, this current is leaving, this current is leaving, this current is also leaving. I will take V minus 150 divided by 20 plus V plus 150 divided by 20 plus V divided by 10 is equal to 0, right? Only one equation. Solve that equation for voltage V. Solve that equation for voltage V. Then how much it is? So V by 20 plus V by 20, then that will be V by 10, minus 150 by 20 plus 150 by 20, that is 0, plus V by 10 is equal to 0. Wow. So here this question is a good question. Yeah, why this is minus 150 positive terminal, why this is plus 150 negative terminal, right? Same 20 20, right? Now V is equal to 0. If V is equal to 0, current I is also 0. No current is flowing, so none of this is the answer. None of this. Yes, perfectly you can check. So no current is flowing. In fact, that is 0. Why? Why? Because this is a source. This is a source of equal impedance. This will give you a current source. This will give you a current source. Both current sources are getting cancelled with each other, right? If you make source transformation, I will tell you that also. If you take its source transformation, you see this is the current source upside with some 20 ohms, but this is the current source with the downside with some resistance 20, or not some resistance 20. What is this current value? 150 divided by 20. What is this current value? 150 divided by 20. Both are opposite. Two opposite equal current sources are there. Net current is exactly 0. If current is 0, so nothing is flowing in that. So it is not 5, it is not 10, it is not minus 5. None of this is the answer, right? Next. An ideal current meter should have, an ideal current meter means ammeter must have 0 internal resistance. Why? It is carrying current. If it is having some resistance, some voltage is going to drop in that. That will change the operation of the circuit, right? Therefore, ideal ammeter must have 0 internal resistance. Yes, an ideal ammeter, right? An ideal ammeter must have yes 0 internal resistance, right? The same way, an ideal voltmeter must have infinite internal resistance too. Both are to avoid loading effect. Okay, if some finite resistance is there, then there should be some loading effect. But practically infinite resistance possible with open circuit, but we won't take it as open circuit. Ammeter must have 0 internal resistance. Voltmeter must have infinite resistance. We connect voltmeter in parallel, ammeter in series, right? So 0 resistance. Option is A. Next question, please. For the circuit shown below, given figure, the voltage VAB is. He is asking about. See, now he is asking about AB, not BA. Now A is my positive terminal. My reference is A. My reference is A. Right? Now let me write here. This is VA, or I do one thing. Yes, convert into current sources. Now what happens? This 5. This is going to become 2 amperes current source, and this is a 5 ohm resistance. Now let's keep this one as. Do not change the targeted terminals. Do not make any changes in the targeted terminals. Keep it as it is. Now this is 50 divided by 10. 50 divided by 10. Therefore, 0.5 amperes to the downside. 0.5 amperes to the downside, and this resistance is 10. This resistance is 10 ohms. Right? Now 2 up, 0.5 down. The net will be 1.5 to the upside. 1.5 to the upside. This is 5 in parallel with 10. 5 into 10. 50 divided by 15. Yes, sir. This is 50 divided by 15, and our targeted terminals is what? This is B. This is A. Yes, how much is this resistance? 5 ohms. Now I want current in this one. Let's take it as IX. Ix is equal to 1.5 into its opposite resistance, 50 divided by 15 by, yes, 5 plus 50 divided by 15, right? Let me write here, yes, Ix is equal to, yes, Ix is the current that is flowing in the AB, yes, in the AB. How much it is? 1.5 into 50 divided by 15 by 5 plus 50 divided by 15. So Ix is equal to 1.5, 50 divided by 15 by 45, 95 divided by 15, 15 gone. So Ix is equal to 1.5 into 50 divided by 95. Then what is VAB? VAB is equal to minus of Ix. Why? He is asking, actually current is entering here. This is plus minus, but he is asking from here, therefore it is minus 5 into, yes, minus 5 into, this current is 1.5 into 50 divided by 95. You must do without calculator. I will do with calculator. I will do this one with calculator. Just a minute. 50 divided by 95 into 1.5 into 5. It is approximately, yes, VAB is approximately minus 4 volts we are getting. Actually 3.94 something we are getting, minus 4 volts, but the option is not matching. Let us see our calculation once. I think calculation might missed it or options are wrong. We'll see it. 10 divided by 5, 2 amperes to the upside, 5 ohms it is. This is also 5 ohms. Okay, right. Now 50 divided by 10. Oh, 50 divided by 10 is, this is 5 amperes. I took it as 100. This 10 ohm. This is 5 amperes to the downside. Sorry, my mistake it is. I'm putting where the mistake here is. 50 divided by 10, I took it as 100, that's why I wrote it as 0.5. Now 5 down, 2 up. Now this is not correct. 5 down, 2 up. Everything is fine except that current value. There, I taken some unnecessary new value, that resistance as 100 ohms. Right here, come here, all of you. This is 2 amperes upside, right? This is 5 ohm, yes. That voltage source in series with resistance we converted into current source in parallel with resistance. This is also 5 ohm. In fact, this is B, this is A. Here there is a resistance of 5 ohm and 5 ohm or 10 ohm, sorry, that is 10 ohm. Let me write the correct value, otherwise we'll commit mistake once again, right? This is 10 ohm, right? This is 10 ohm, this is 10 ohm, and the current is to the down, that is 5 amperes, right? Now 2 up, 5 down, 3 will be down, right? 3 amperes will be down. Now I am drawing it. 3 down, yes. Now this is 5 ohm, this is 10 ohm, this is 5 in parallel with 10, 5 in parallel with 10 is this, and this is your target terminal. As I told you, we should not disturb it. This is B, this is A. Yes, your current is entering here only. This is plus, this is minus, right? VAB is equal to current 3 amperes, the total current is 3 amperes. Observe here, 3 amperes into opposite resistance 5 in parallel with 10 divided by total resistance is 5 plus 5 in parallel with 10. 5 plus 5 in parallel with 10. Now what is 5 in parallel with 10? 5 into 10 by 15, 5 3s, that is 10 by 3. So VAB is equal to 3 into 10 by 3 divided by 5 plus 10 by 3. Now VAB is equal to 3 into 10 by 3 by 15, 25 by 3. This 3 gone. How much it is? 30 divided by 25. So how much it is? 30 divided by 25. How much it is? Yes, 5 6. Yes, 5 6 5 5. Yes, 5 6 5 5. How much it is? 1.2 volts. It is exactly 1.2 volts. But now also it is not there in the options. Check the, I think options are wrong. This time we are perfect. 10 divided by 5, 2 amperes up. Okay, 2 amperes up. This is 5 ohms. This is also 5 ohms. Okay, 50 divided by 10, 5 to the down, 5 to the down. This is 10. 10 in parallel with the 5. 10 into 5 divided by 10 plus 5. How much it is? 50 divided by 15. Yes, 50 divided by 15. Right? Check this calculation once. yes, 5 in parallel with 10, 5 in parallel with 10 will be, yes, 5 into 10 by 15, 5 threes, 10 by 3, we 50 divided by 15, nothing but 10 by 3, yes, VAB is equal to, total current is 3, why 3 sir, 2 up, 3 down, therefore 3 down we taken, 3 into opposite resistance. I want voltage, I want the current through this 5 ohm, I want the current through this 5 ohm, so this resistance in the numerator I have to take, perfect, divided by total resistance 5 plus 10 by 3, 5 plus 10 by 3. Now 3 into 10 by 3 by 5 plus 10 by 3, this is 15, 25 by 3, 3 gone, 3 into 10 divided by 25, perfect, our answer is perfect, okay. Forget about the options, maybe options got missed over there, right. Now look at this question carefully. What is saying? The value of the resistance R shown in figure given below is, he is asking about the R, the resistance R. Good question. 4 amperes is entering here, then what is the voltage here? This voltage is 4R, na? This voltage is also 4R, why? Because both are in parallel. Then what is this current? 4R by 7. This current is 4R by 7. Very easiest logical way. This voltage is 4R. How sir? What is the current? 4 amperes. Resistance is R. Total voltage is 4R. This were in parallel. If this voltage is 4R, this voltage is also 4R. If the voltage is 4R, then the current will be 4R by 7. Why? Because voltage divided by resistance, this resistance is 7. Now what is this current? This current will be the total. What is that? 4 plus 4R by 7 is the total current. Now you write the KVL. Minus 50 plus 6 into 4 plus 4R by 7 plus 4R is equal to 0. That's all. Is equal to 0. That's all. Now come here. 50 is equal to 24. Yes, plus 24 divided by 7R plus 4R. Right? Yes. Calculate it. Yes, calculate it. I do the calculation. Yes. 24 divided by 7 plus 4. 7 point, see, this is this one I calculated, 7.428 R is equal to 50 minus 24. 50 minus 24 is 26. So R is equal to 26 divided by 7.428. It is 3.5. Answer is how much? 3.5. Exactly option A is matching with this. Exactly it is option A. Right? Let's go to the next question. The resistance of a parallel circuit consists of two resistances. Two resistances 12 ohms. Okay, he's saying that the resistance of a parallel circuit consisting of two resistances 12 ohms. Okay, he's saying that there are two parallel resistances. This resistance is 12 ohm. How much it is? R equivalent is how much? 12 ohm. This is, let's take it as R1 and R2. What is R equivalent? R equivalent is equal to 12. That is equal to R1 R2 by R1 plus R2. Fine, very good. Then one of the resistance wires breaks and the effective resistance becomes 18 ohms. He is saying that if one of the resistance is breaked, yes, suppose R1 is breaked, now R2 is there, now this resistance is 18 ohms, then simply R2 is equal to 18. R2 is equal to 18. Now what is asking about then? He's asking about R1 is how much, right? Observe it. Then the resistance broken wire is, that is very simple. 12 is equal to R1 R2 by R1 plus R2. Yes, R2 is equal to 18. Put there. 12 is equal to 18 R1 by 18 plus R1. Now simplify it. Yeah, 18 into 12. I do with the calculator, but you should not do with the calculator. 18 into 12, right? Into 12. 216. 216 plus 12 R1 is equal to 18 R1. So 6 R1 is equal to 216. So R1 is equal to how much? R1 is equal to 216 divided by 6. It is 36 ohms. So R1 is how much? 36 ohms. Right? R1 is 36 ohms. Option is C. C for Chennai. Right? Let's go to the next question. Let's go to the next question. The approximate equivalent resistance at the points x1 and x2 in the circuit shown below is, right? So this series combination is 50. 50 in parallel with 40, that is in series with 10. So R equivalent is equal to, you stand here as I told you, 50 in parallel with 40 plus 10 plus 10 plus 40 plus 40. Why is there downside also there is a resistance? This is to this total combination, these two will be in series, right? Now that is in parallel with 40, that is in series with 10 plus 10, in series with 10 and 10. Very simple. See, I'll do this with a different color. These two, this 10, this 40 are in series, right? That became 50. That 50, sorry, this downside 10 is also there. Total it is 60, not 50, 60. 10, 40, 10, 60 in parallel with 40. 60 in parallel with 40, how much it is? Let me calculate it. 60 in parallel with 40. 60 into 40 divided by 100. Need not to have any calculator. It is, I think it is 24 ohms. Why? Because 60 into 40 divided by 60 plus 40 is 100. 0, 0, 1. It is 24. This is 24. This is this total became 24. The 24 plus 10 plus 10. 24, 34, 44. Right? Yes or not? That is 44. See, 10, 40, 10, 60 in parallel with 40, 24. 24 plus 10, 34, 44. 44 in parallel with 40. So this total is 44. 44, yes, this total is, just a minute. 10, 40, 10, 60. 60 in parallel with 40 is 24. 34, 44, 44 in parallel with 40. Yes, correct only. Ours is correct. Ours is correct. Just a minute. 44 in parallel with 40. Yes, 44 into 40 divided by 84. Right? 20. That is 20. Yes, 20 plus 10 plus 10 plus 20. Almost it is exactly 40. You get a 40 ohms. That's all. Yeah. So this total you got it as 20. This total up to here you got it as 20. 20 plus 10 plus 10, it is 40. It is how much? 40 ohms. Right? Very simple. See, you may be thinking, sir, you did it very clumsy way. Why? Simple. 10, 40, 40, 60. 60 parallel with 40, 24, 34, 44. So up to here overall calculation. 40 in parallel with 44 you will get, that is 20. Now that 20 is in series with 10 and 10 and 10. How much it is? 40 it is. Right? It is 40. Let's go to the next question, please. Let's go to the next question. Yes, the next question is also a very easy question. Yes, it's also going to be a very easy question. Yeah, for the circuit shown below, the current I flowing in the circuit will be, he's asking about the current I, right? So this is the current I is asking. Now if you draw it carefully, this is A, this is B, this is C, this is D. Total 4 points are taken, A, B, C, D. I'll take A, B first, A, B. Between A and B 3 ohms is there, okay. But B and D, both the points are same. B and D, this is B and D. And in the same way, A and C both are same. Now tell me, B and C, there is some resistance of 3 ohms. Yes, B and C, there is a resistance of 3 ohms. Between C and D, yes, this is C, this is D. Yes, there is a resistance of 3 ohms. Simply all are in parallel, all are in parallel. This is 3 ohms, this is 3 ohms, this is 3 ohms. Yes, this is 12 volts. Now he is asking about this current I. He is asking about that current I. Tell me all of you, what is that current? Tell me, what is that current? Yes. Very simple thing. Very simple thing it is. That current will be, yes, 3 in parallel will be 3 in parallel with 3 in parallel with 3 will be 1. Now the current I is equal to simply 12 by 1 is equal to 12 amperes. Answer is what? 12 amperes. But it is, so it is 2 volts, sorry, not 12 volts, it is 2 volts. Then 2 divided by 1, it is how much? 2 amperes. How much it is? 2 amperes. Option is C. Very simple question. Very simple question, right? Yes or not? Let us go to the next question. Two resistances R1 and R2 give combined resistance of 4 ohms when series. So simply R1 plus R2 is equal to 4.5 ohms, right? And 1 ohm in parallel, okay? R1 in parallel with R2 is equal to 1 ohm, right? Now the resistances is asking. So what is R1 in parallel with R2? R1 R2 by R1 plus R2 is 4.5. S is equal to 1. So R1 into R2 is equal to 4.5. So let's do this, check these two things, that's all. Multiplication should be 4.5, addition also should be 4.5. So this is option A is not correct. Option B is also not correct. 3 into 1.5, yes it is. Multiplication, addition 4.5, multiplication is also 4.5. Option is C. You need not to solve it, directly we will get, right? Next question please. The value of R for I is equal to 2 amperes. He is saying that this current is 2 amperes. This current is 2 amperes. Therefore, this is plus or minus 2. 2 into R, this voltage is 2R. This voltage is 2R. This is 10 amperes. This is 10 amperes. In this one, some current is flowing. How much current is flowing this way? 2 amperes. Then how much is this current? 8 amperes. Apply the KVL for this loop. That's all. So minus 2R, 2 into R, 2R, plus 80 plus 40 is equal to 0. So 2R is equal to 120. R is equal to 60 ohms. R is equal to what? 60 ohms. It's a direct answer. It's a direct answer, right? Next. An ideal current source is the one whose internal resistance is infinite. Ideal current source internal resistance is infinite. Ideal voltage source internal resistance is 0. Ideal current source is infinite. Voltage source is 0. Right? Next. A 10 ohm resistor is connected in parallel with a 15 ohm resistance, and the combination in series with 12 ohms, the equivalent resistance of the circuit is. He is saying that a 10 ohm resistance is connected in parallel with 15 ohm. Yes. A 10 ohm is connected in parallel with 10, this is 15, and the combination is in series with 12, this is 12. Now he is asking this equivalent resistance. What is 10 in parallel with 15? So 10 into 15 divided by 25, so 5 5s, 5 3s, right? So 30 divided by 5, so that is 6 times it is gone. 6 plus 12, it is 18 ohms. Answer is 18 ohms. Option is B for Bombay. Direct. So this, see, these most of the questions here, 50% of the questions are previous ISRO questions. Okay, don't think that we are dealing with simple questions. Questions are simple but logical and easy. Here, they may get some people may get confused about this combination of resistances. Okay. Let's go to the next question. 3 resistances, 15 ohm, 10 ohm and 3 ohm are connected in parallel, and the overall resistance is, see, this is the direct question, that is, whenever resistances are connected in parallel, then the resultant resistance will be less than the least value of the resistance. Therefore, answer is less than 3 ohms. Yes. Whenever resistances are connected in parallel, then the resultant resistance is less than that of the least value of the resistance. Less than that of the least value of the resistance. What is the least value of resistance here? Yes. What is the least value of resistance here? Come on, man. The least value of resistance here is, that is the 3 ohms. In the combination, it is 3 ohms, right? Yes, all of you. Let's go to the next question, please. Next question. When 3 resistors, they are not resistors, each having resistance of 18 ohm are connected in parallel, then the equivalent resistance is. This is also direct question. R equivalent is equal to R by N. When N resistances of equal value are connected in parallel, then here 18, number of resistance are 3, therefore it is 6 ohms. Option is B. Option is B for Bombay. Right. Next question. Determine the current I1 in the network. He is asking about this current I1. This current I1. Okay. Now tell me, this 14, this 32, both are in opposite. 14 minus 32. So 34 minus 14 will be 20. 20 minus 2 will be 18. This voltage is 18. V2 is 18. Now what is this current? V2 is 18. 18 divided by 40 is this current. 18 divided by 40 is this current. V2 is how much? 18. Sir, how you are telling V2 is 18? So this source both are in addition, means plus subtracting, getting subtracted as the polarities are opposite with each other, opposing with each other, then that is in parallel. Therefore, V2 is 18. Right? This current is 3.5, this current is 2 ampere. Now this I1, so you need not to do all this nonsense. You need not to do all this nonsense. See, forget about the previous one. See, this is a 2, this is 3.5, this current will be 5.5 amperes, that's all according to KCL. That is a 5.5 amperes, option is C. Just to confuse us, that fellow, that given unnecessary data. Okay, so this is the node, incoming current is I1, outgoing currents are 2 and 3.5. I1 is the incoming current, outgoing currents are 2 plus 3.5. How much is I1? I1 total is 5.5 amperes, that's all. Option is C. Right? The current I in the figure shown below is asking about this current I, right? Now observe here, you can convert this one into voltage source in series with resistance, that is 4 volts in series with 2. Now this is 2 ohms, this is 2 ohms, right? 2 ohms. Now this is 2 into 0.53, yes, there will be a resistance of 2 ohms, and this is what, 2 into 0.5, 1.5. 2 into 0.5, 1.5. Now he is asking about this current I. So I is equal to 4 minus 1.5 divided by 2 plus 2 plus 2. All are 2. It is 6, right? Therefore it is 3.5. Yes, no, 2.5 divided by 6. Answer is 2.5 divided by 6. So 2.5 is 5 by 12. It is in fact 5 by 12. Let's calculate it. 5 by 12. 0. Let me calculate with the calculator, but you guys must do without calculator. Yes, 5 divided by 12. 5 divided by 12. It is approximately 0.41. But options are not exactly matching. Let us see why options are not exactly matching. This is 2 in parallel, 2 amperes, 2 ohms. Therefore 4 and 2 it is. This is also 2. This is also 2, but 1.5 to the upside. 4 minus 2 into 1. Sorry, this is 1. Here my calculation mistake, this is 1, not 1.5. Come on man, this is 0.5 into 2, 0.5 into 2 is 1. Now this is 1, this is 1, 2 by 6, so this is 3 by 6 now, 3 by 6, 3 by 6, how much it is, 1 by 2, sorry. It is what, 1 by 2, that is 0.5 amperes. I committed a calculation mistake. Procedure wise there is no mistake at all. The calculation mistake is 0.5 into 2, that is 1. This is 1 volt from source transformation, right? Yes or not? Yes. Let's go to the, see, these are all the 20 questions from basics of networks. This way, see, one step I taken, for hardly I taken one step. Calculations you must take care very clearly, right? Because calculator is not allowed, right? So this way we will cover all the subjects, all the topics, all the chapters very clearly in the direction of ISRO examination. All the best and thank you.